So begins another draft physics video presentation. Pretty sure, anyway. Yeah, microphone. Well, close enough. Anyway, so some comments and see where it leads, sort of. So some, love your videos kind of stuff. Nice, thank you. Blah blah blah. Anyway, we'll just read the snarky shit. Or the something added value shit. So anyway, some guy says, by the way, Bill Gates has debated an actual particle physicist. Yeah, he was like 16 years old though, so it wasn't much of a debate. And frankly, I find Bill's whole argument useless, and that she just gets into all this semantic crap about what belief is and all this other mush, and some of his fundamental arguments I think are just garbage. Like somehow it isn't about doing experiments, when you first have to know what something's doing before you can describe why it's doing it. So you really have to do as many experiments as possible to glean knowledge of what's happening before you can attempt to describe what's happening. So, I mean, it's essential to the process. So anyway, yeah, and this JF guy, whatever, PhD in biology and neuroscience, it's hard to imagine just because he doesn't seem that smart. And we sort of have like a personality conflict, just in the sense I hate, French sound and douchebaggery, and he's just so pompous and all that kind of crap. But yeah, I would like to talk to anybody, frankly. Relevant. I guess I'd also argue I'm not like rushing to do it, just because Bill doesn't seem to gain any traction from the encounters. So it's not like it's a some sort of view pool you can jump into and get lots of views out of it. Yeah, so I have, it's all got some, who cares? But, I'm not opposed. I'm just not aggressively seeking. So anyway, that's all I can say about it. I mean, I wish I found the interviews fascinating, but I just found them tedious, and I really don't like people doing whatever shows, the people's whatever he calls it, and it's just, yuck. I mean, it's a really cheap version of what, Joe Rogan or something? Really cheap version. So anyway, Ken's finally catching on somebody's nerves. Okay, so I guess a satire jokey thing there. DraftScience has a playlist dedicated to his word salad. So yeah, this was sort of an interesting thing, whatever this is. DraftScience, that's what it's called. The guy's okay. I mean, I like his style. It's that whole British kind of low-key thing, which is nice, but frankly, it's just playing a bunch of Ken Wheeler videos, and just, yeah, for anybody who's intelligent, it's impossible to, what the hell is he saying? It's all mush. And so, but that doesn't really get to the point that clearly people are intrigued by mush. Clearly Ken's really popular, this guy's doing okay, but Ken's winning. The Ken types are winning the argument, because somehow, like I say, if you do try to explain regular physics, you're going to just sound like it's much word salad. I mean, bent geodesic. It's a bent geodesic, trust me. The virtual photons are entangled. I mean, it's just as bad, frankly. The conventional explanations seem like such a cop-out. The multiverse is, yeah, we can't figure out what exactly happened, so we'll say everything happened. Okay, it just happened in some other universe. There, that solves it. I mean, it's really pathetically bad. So yes, maybe, I mean, and physics has plenty of jargon, right? I mean, their whole structure is hidden in jargon. Their mathematical symbols and their wave function notions. It's a wave function, even though there's no explanation for what the hell that would be exactly. Yeah, it's pretty bad. So anyway, I did send him an email suggesting we should have a conversation, but we'll see if it gets me anywhere. Probably won't. Nothing. It's okay. I don't even get replies from these people. Alright, so I guess that's all there is to say about that. So we're already moving on to, the cliche troll comment. This crack addict. So again, you could say that on every video on YouTube. You disagree with somebody, just you're a crack addict. Fine. In the back of some pet shop. So that's the new bad thing to do, is be in a pet shop or something. I mean, I tend to. In my youth, I liked pet shops. Liked watching the fish. Who can't read. Well, I always can read enough. So is there some standard of literacy we all must have to satisfy you? Oh, God. These people are so bad at making arguments. I mean, just, you're living your life, and this is the best you can do in terms of making an argument, is just insult after insult after insult and just never get to anything relevant or that could possibly be meaningful. All right. Is talking shit on a Caltech professor. So I didn't talk shit. What I did was disagree, and I pointed out why I disagree. I mean, there's these fundamentally obvious, I think, almost kind of arguments that could be made where no fair person could say, oh, gee, you're being completely irrational to disagree with their physics, because their physics is so super cool and fantastically understandable. When it's not. It's overtly contradictory and illogical. And you can point it out with these simple experiments that say that the foundation of their wacky conclusions are things like the two-slit experiment. And then you can point out how, they've glorified this name, Young, the Young two-slit experiment. And you can just point out how historically Young didn't do anything Newton didn't already show the world. Everything Young provided, Newton had already done. And the rings are actually named after him, for fuck's sake. I mean, it's hilarious. It's so stupid. And you're saying that I can't do that. I can't point out how their version of history is nonsense and their understanding of the concepts is superficial. And it just is. It's just a fact. They never really thought about it. All they did was go to college to do math. They didn't go to college to learn how things work. They probably can't fix their own cars. Anyway, seems legit, fucking buffoon. With some little emoticon in the middle. Yeah, brilliant argument. It seems legit that this kind of crap is anything but just a waste of every human being's time. You didn't make any kind of argument. You just called me some names and that's it. You didn't accomplish anything else, and you think that's the way the world should work. So anyway, I did go to his channel. He has one. Okay. Little pretty fellow. I believe that's Mitch, doing some buffooning, frankly. And this is apparently went to college to do this. So it's not only not funny, whatever it is, I don't even know what it is, but it's apparently went to college for this.
If I could have everyone's attention, please. You can all raise your glass. This is Keaton Gleason, and I am his best man at his wedding, so this is my speech. First of all, I'd like to thank everyone.
What's he marrying? Afraid to even look. I'm afraid to look. But anyway, I want playback speed. Yeah, zoom this up a little bit.
Come out tonight, see this woman get married. I know it must have been a real shame to get that invitation in the mail, but we all had to sacrifice. And look at me, I'm standing up here, dressed like this, just like a few years ago, right? Yeah. First of all,
it's sort of a cross between me and Fake Sagan, maybe. Yeah.
Paul, I'd like to start out with a quote. And that is, if you don't have sauce, you're lost. But you can also get lost in the sauce. That's from...
Okay, now it's really funny, right?
the famous Gucci Mane. Now, Keaton here has sauce. And the first example of that is, we've known each other since kindergarten and...
Yeah, little fuck buddies, I guess.
Elementary school. And,
bad Abbott and Costello routine.
As a kid, we played sports together, football, baseball, track, and he was tiny.
Yeah, run up your butt. He was tiny. It's the way you needed it back then.
I'll tell you that. And honestly, I can't believe he actually cuffed one girl because we could not keep the chicks off of us, honestly. But as a kid, honestly, Keaton was the smallest of our group. But that was all right because as teens, you know what?
You like him that way.
He was still small. However, it got better, as college kids. He was still small, but we had some good times.
This is almost like now we're floating right into the cringe worthy. I mean, it's just so getting so cringy.
Vegas together. We had some.
I'm just doing this for posterity, right? Look, I'm right. That's going to be noticed eventually because they're going to figure out that, you know, all this wacky shit we're talking isn't getting us anywhere. We're spending all these billions and billions of dollars on all these wacky, stupid ideas, and none of them are producing a cup of, you know, a better styrofoam cup. I mean, we're not making anything out of this crap. You know, it took 27 years to figure out how to make a blue LED. You know, I mean, this isn't working. And they're going to figure that out eventually. And then they'll say, oh, let's go find the right answer because these silly answers are silly. You know, the computer that doesn't need to compute. You know, it just goes straight to the right answer. You know, it doesn't have to do any of the figuring out. No, it just jumps right to the answer. Yeah.
Some awesome times on the golf course. You know, we spent a lot of time bonding, and the brotherhood that
Oh, really?
that we formed together on those days is unlike anything else. We may not look alike, but we are brothers. And
Or sisters. It just depends on what we're wearing that day.
look how far we've come, Keaton. You know, from kindergarten basketball to best men, and you know, honestly, I wouldn't trade any of this for the world.
You wouldn't? Yeah, see, I wouldn't be paid anything to be you. Okay, being you would be really humiliating. And yes, you'd have to, you know, you'd have to give me more than whatever 70 virgins in a wonderful heaven for a few million years before I'd ever think about risking it all to be you.
And you know, just seeing how happy this girl makes you reminds me a lot of me. And you did this at my wedding a few years ago. And
Oh, sucker. Oh, hilarious. Now I really don't want to be you. Double.
just to see the growth that you have had since that time coming till now, it just shows what kind of person she is.
What is this? Why is this video on the internet? I mean, you know, I could turtle on rock, you know, much better video.
As well as what kind of person you are. And it also makes me proud of myself, you know, because I was such a good role model for you, Pete. But, you know,
So, I mean, obviously this is some put on of some kind. It's some, like, pageant. You know, they're pantomiming. You know, for what purpose? I mean, couldn't be a rehearsal of some kind. That would be impossible.
what I think we all take away from this is that love has no...
Oh, gee, love. So you're going to call somebody ignorant or a buffoon or stupid or unqualified or something else, and you're going to throw a word like that around. Like that word means something to anybody with a reasoning mind. They say, oh yeah, I totally get love.
boundaries, and that is shown by Keaton and his girlfriend, because obviously there is something wrong with her eyes. He is hideous, right, folks? And
Well, you know, see, this is just how cruel life can be. This guy is just so owned by his inferiority and his, you know, just his baitedness that he's just settled right into the role. Go ahead, say something just too true right to my face. I'll take it.
I'm just kidding, because Keaton...
Oh, yeah. Too late for the I'm just kidding. You know, you've already called her a fat ass. It's already been done. You can't really, I'm just kidding. No, that won't work.
Obviously, we love each other, and
Oh, spooky.
we're going to be continuing to do stuff like this for the rest of our lives, because we are more or less brothers.
Creepy.
Everyone, cheers.
Isn't that sweet? Little glass of semen. Well, that was just too fucking strange. So it's another thing for physicists to figure out. Why the fuck did that happen? You know, I mean, of all the possibilities in the universe, how did I end up in the universe where that fucking happened? Gee, it seems so improbable. So anyway, fuck you, troll. I mean, you're just such a stupid, ignorant twit that you can't figure out. You know, you're sitting here going to college and you still can't figure out that you shouldn't open your mouth unless you got something you can defend. You can say something relevant and meaningful. You can't do that. Yet you're opening your stupid mouth. You're just being a cliche, the definition of the cliche, stupid human. Alright. That's all he's got on his channel is 2 videos that look too similar for me to be bothering listening to both. So anyway, I'll pass on that. Alright. So, yeah. Oh, let me go to the... Oh, fuck you. Jesus. Idiot. Alright, so anyway, Mitch B. Check him out. Really interesting. Alright, so I would just throw something in terms of why physics is this foolish and how could they fall for this crap and why can't they really spend a little bit of time thinking about it before they commit to such wacky ideas as multiverses and bent geodesics as explanations and, you know. So, there's only 2 things going on in the universe, right? Well, I mean, there's one obvious thing that we see all the time is thing rolls into another thing and, you know, like the background image. I guess I could just put that there. Hell with this crap. You know, the kinetic ball thing, you know, A hits B, you know, and, you know, B moves and A stays here or whatever. There's this moving thing that happens and it's basically always a push. So even when something's pulling on something, it's usually because it has a hook and it's actually pushing, you know, not pulling. You know, that's how, what, 99% of the universe, and the big universe is working. We see real things bang into real things. We see real wind blowing. We see lots of real things. And the problem is they have this 2 things. They have the Earth, kind of, the big universe has objects in it, and the objects seem to be moving towards each other. And, but we don't see the objects repel each other. So in the big universe, there's no go away. There's just this one moves towards that one and this one moves towards that one, and they sort of got that. And then they have this weird magnetism electrical thing where these electrons and proton thing react completely inversely to this, you know, with this magnet thing. So I can put a magnet in here and this side will repel the proton and this side will repel the other way around. This is the attraction side. So the electron's attracted to the south side, the proton's attracted to the north side, and there's this inverse relationship where they're repelled by the opposites. That's it. That's all there is in the universe, and they have to do this with bent space, okay, and then they have to throw time in there for no good reason. And to explain this, they just come up with, well, there's this virtual thing that's like a photon, except it does this pulling thing. So a little bit shoots out and hits it and somehow tells it to go this way. You know, so it's exactly nothing like the steel ball, right? So there's this steel ball hits, and for some dopey reason, the steel ball, I don't even know how to describe it, right? Because it's sending a message. So this one hits this one going this way, and then this one goes that way. Nothing like that in our real world. Not even close. And then the whole ESP of entanglement is just too silly to even bother wasting time on. Alright, and all this is based on different experiments that confuse them a little bit. So they had this, like I said, this young guy showed up and he did an experiment, right? And the experiment said to them that this single thing, this photon, meets these 2 slits, and somehow it does this thing where it's going to end up, you know, in locations. So each time I send this photon in the same way, it's going to come to different places by a different amount. So 90% of the time it'll go here, but, you know, 5% it'll go here, and 5% here, and, well, you add it up, we'll say 85%, and we can cut 2% down here and all that kind of stuff. And they're saying, how does it do that? Well, it must go through both slits, and it must turn into waves, and the waves interfere with each other because that's what water does. So yeah, it does something similar to what water does. But it's only similar. It's nothing like water, really, because water agitates this, up and down, where this is only on. It isn't on and off, on and off. And this isn't like half a photon. Okay, it's off. So anyway, it's not exactly the similar or any of that kind of stuff. Well, anyway, so they decided with this silly answer that it's a particle, but now it's a wave, and it creates two new waves, and blah, 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 blah. Now, but the problem is, it behaves like water is their conclusion, because water does this interfering wave thing. They figure photons must be doing interfering wave things. But they can deduce that that can't be the right answer because, as Newton showed, because Newton did all of these experiments. I mean, he did the two that are necessary. He did this experiment and he did this experiment. So he did this single impediment, where the light appears to go around both surfaces. And then he did this experiment where there's the two surface phenomenon again, where there's surfaces and you get pattern. And so that should tell them right away that they can't get away with this photon splits in two stuff, because it doesn't make any sense. There's nothing to make your two waves out of in the single slit. So I'll point out the single slit, they're saying it does the same thing as the double slit in the sense that this single particle turns into two different kind of wave functions, two waves for no reason. There's absolutely no reason why it should split into two waves and then create a pattern. All right, because what they're not getting is what's really important is there's two surfaces here, and what they're also not getting is the photon isn't a little tiny thing. It's made of little tiny things, but it's actually spread over a rather wide area. Photons are thousands of atoms in polarization. Okay, this is something everybody knows photons have, is polarization. And they're huge. Their polarization is huge. And so, the more reasonable answer that you're committing some crime against your own intelligence, right? I'm committing some kind of rational crime to think it's possible that they could be wrong in their interpretation and that some other explanation could be possible. Now, Newton couldn't speculate on it because, well, he didn't know enough about this kind of stuff as we know. So Newton just left it an unanswered question. He tended to believe, logically, that the light was particulate, but he couldn't really say what it was. Anyway, so you already have right here in the single slit an experiment that's telling you this water answer, right? Oh, it's just like water. Okay, it's waves traveling through a medium where the atoms have adhesion, that is, they're stuck to each other, they have tension between each other. So, what happens to one has to happen to all the rest. So yeah, we should believe that the universe is made out of water. That's what they're saying because of this experiment. Now this one clearly points out that water's not the answer. Okay, that stupid wave crap. There's no reason it's going to create two equal little waves here to interfere with each other. There's just no reason for there to be two waves here. You have the two slits here, so they have a reason to make up this silly story about the photon going through both. But you got no reasonable expectation that that's the rational argument for this experiment. And what's more rational, or what's a better explanation, is this photon is made out of bits that cover a lot of area, okay, and it has a frequency. And what's happening is this pieces of it are getting broken off. Pieces are getting removed, and the photon is broken when it goes through the slit. And then the other thing the slit's doing is there's a bunch of electrons on this surface, and the electrons are all giving it a little bit different angle that it leaves at. So the fragments of the photons are all going out in these different directions. And what's simply happening is if you have these distances, the right distance between these two slits, then you can reconstruct, okay, the phase of the photons, that is this part, from two different photons and create a new photon here. So it's new. I mean, it's been manufactured out of two olds. Okay, so I mean, two old photons combined here. Now it could even be three photons, because you have this spot and this spot and this spot and this spot. All these spots are going to deflect the light at different angles. So you could even have a component coming from there and a component coming from here. And as long as the distances are multiples, harmonics to this correct phase, that is, it puts them back on phase, you can reconstruct the pattern out of pieces of the pattern. So you can have dot, 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 and you can have dot, dot, and you can have all kinds of little dashes. And if these angles are correct, like even this angle can be more than a wavelength, because actually you're going to take two photons from two different wavelengths and reconstruct them. But I don't want to get into that. And that's why you have different colors. So the blue ones you're going to see sooner, because the change in the distance that you're traveling, okay, is going to be less when you're reconstructing a blue photon. So that'll show up here, and then the red will show up over here, and then the next blue will show up here, and the next red will be over here. It's a little bit off because the blue eventually disappears here. But anyway, and that's what's seen if you put white light in. But anyway, it tells you, like I said, this is glaring. It's saying right to you, it doesn't do that in water. Water doesn't create two waves. Water doesn't create an interference pattern. There's nothing to split the wave in half. Nothing. So it doesn't happen. And it might a little bit on the fringe here, just because some of the water, see, we know why water does it. It's because the water slows down here. Next to the surface, there's friction. And the friction, okay, causes the water to slow down. And that's why you get some, a little tiny bit of it over in these fringes, but that's it. But this is the foundations of their physics, right? They draw a conclusion. The conclusion is kind of extraordinary. Oh, it goes through both slits and turns into something called a wave function. And then the wave function goes everywhere, except it doesn't really. It just lands in one place. And all the energy that it wasted going over here, somehow that just disappears from existence in the universe, and all the energy went here instead. I mean, it doesn't make any sense. It doesn't fit the evidence. It doesn't fit as a reasonable explanation. It's an extraordinarily wooey, silly explanation. And I'm somehow some sort of thought criminal, some sort of, logic murderer, by saying, no, there's better explanations. They just didn't think about it long enough. And you could argue they just didn't think about it well enough. I don't know why it got so myopic so quickly, but I mean, it really became some kind of contest between, wave versus a particle. Not close enough. And they just didn't want to be bothered, so one had to win and one had to lose for whatever reason without there being a complete evidence. And I'm just saying, this is the actual universe. This emerges out of it. Particles make waves. Alright, if I put a bunch of soldiers on a battlefield, I can make waves of soldiers at precise intervals. We've seen it. You see waves being made out of particles. You don't see, particles making waves, and especially loose particles. That is, particles that are free and not tied to each other by some mechanism, like in water, for example. So it's just more rational to understand that the particles don't wave. That's a group function. That's what groups of particles will do, is create the illusion of a wave. But there is no wave. The individual bits are all individual bits doing individual things. and you have to account for their travels. The single particle can't go everywhere, and then once it gets somewhere, decide, I didn't go here, I didn't go here, I didn't go here, and I didn't go here, I only went here. It just doesn't make any sense. Retracting energy doesn't make any sense. Making energy disappear or pretend it didn't happen. You can't do this. You can't do this to something as discrete as a photon and say it's going everywhere. It's not going everywhere. It's not doing all of this. Each one is going a specific direction. And yes, as a group, you can say they're going everywhere. You know, what's the million photons doing? Well, yes, a million photons, you'll get some going everywhere. But the individual ones aren't going everywhere. But anyway, I mean, I shouldn't have to defend myself, but for finding that incredulous, as an explanation, that this wave theory, it doesn't fit the evidence, and there's no continuity between the experiments. It's just not consistent. Doesn't explain what we actually do see if you study what actually is seen. And what else? But look, the evidence is that yes, Ken Wheeler's garbage, nonsense physics is popular. Conventional physics, with all this woo in it, is popular. People want to believe these fables, these fairy tales. And then it's ironic that somebody like me, who says these are fairy tales, gets called anti-scientific when it's sort of the job of science to point out fairy tales, to do the Darwin thing and point out the evidence demonstrating that this theory of God is silly. These theories of woo are silly. And there's so much evidence for the better theory that you have to account for where the energy comes from. The Earth and the Moon. The Moon doesn't move into the Earth because space says so. There's an actual force. There's an actual mechanism that's motivating the electrons and the protons inside the Moon to move. They're being hit by something. They're not just sitting there saying, I was told to move. That's not happening in the real universe. You have to account for the behavior. And the same with the magnet. There's no virtual thing. There has to be something real, and you have to account for where it came from. And the only place it can come from, because it's energy, magnets move into each other. They do all kinds of things. When you have them the opposite way, they turn and then they move in. They do real things that take real energy, and you have to account for where the energy comes from, because this doesn't burn any energy and this doesn't burn any energy, and yet they move into each other, and you have to account for where it comes from. And the only place it can is from the outside. It's a push universe. Alright. Whatever. I can only attempt to reason, and you people aren't even trying. That's just a fact. Too many of you aren't even trying to be reasonable. Alright, so maybe I'll just pause it because, I don't know. Should I bother with the Chappelle people? Probably not. Alright, so I'll call it a video. Till next time and such.